In this video, I want to show you some examples of using the normal curve table, which can be found on pages 673 through 676 if you're using the 6th edition of Statistics for Psychology by Aaron et al. And these problems can be quite tricky. I'd say this is where some of the material starts to get more challenging. So I do want to show you a visual example of how I think about it and how I would solve it. Now, in the chapter 3, if you're using this edition at least, Aaron and them give 5 steps for answering the sorts of questions we're going to be answering. And I do encourage you, please do these 5 steps when you're answering them. But in this video, I'm not going to go step by step through those steps exactly because I want to show you kind of how I think about it in understanding it better. And a couple of these steps that they show you involve drawing a normal curve and then estimating something before you find the exact right answer. I'm not going to do the drawing and the estimation, but I do encourage you to please do that. So the first sets of problems ask you to figure the percentages of scores above or below a particular raw score or z-score using the normal curve table. The other sets of problems also involve 5 steps, and they're related, but they're different. It's kind of the reverse. Here you're going to be figuring the scores, either z-scores or raw scores, from percentages that are given to you using the normal curve table. So let's take a problem from set 1 at the end of the chapter. This is problem number 6. And by the way, you can see the answers to all of these set 1 problems in the back of the textbook. So number 6 says, a psychologist has been studying eye fatigue using a particular measure, which she administers to students after they have worked for 1 hour writing on a computer. So you stare at the computer for a while, your eyes get tired, eyes get fatigued. On this measure of eye fatigue, she has found that the distribution follows a normal curve. Hence, we can use a normal curve table. Using a normal curve table, what percentage of students have z-scores, and let's just take the first one to start, have z-scores below a z-score of 1.5? And then we'll do the rest a bit later. So we need to first look at this normal curve table to see how are we going to answer such a question. So the normal curve table looks like this, and we have 3 columns to deal with. These columns over here are just more of the same. The first column just says z, so that's your column that's going to tell you what z-score you're looking at. The next column says percent mean to z. So this is telling you, and there's also images up here, telling you what these numbers are representing. So this column says percent mean to z, and what the numbers here mean, it's giving you a percentage of the scores that fall between the mean and that particular z-score. So let's take the first number. Looking at a z-score of 0, what's a z-score of 0? We've seen earlier that the mean is always at the z-score of 0. So this is saying there's no scores between, and it's not exactly true that there's no scores at the mean, but there's no scores between the mean and there's no other anchors. It says 0% right here. But the percent from the mean to the end of the tail, in a perfectly normal distribution, we know that's 50% because 50% are above the mean, 50% are below the mean. And so what you'll notice as you go down these columns, the z-score is going to be getting larger. In the table, the z-scores are always positive, but we'll see that the same applies whether the z-score is positive or negative. So the z-scores are going to be going up by 0.01 as you go down the table. And as they go up, the percent mean to the z is also going up. And you'll see the opposite is true for the percent in the tail. So it's going to start, because all the scores are between the mean and the end of it, at 50%. And as you increase your z-score, really what you're doing is going from here across here. So the percent from that point to the tail is going to be getting smaller and smaller. So let's go back just to remind ourselves of the problem. It says, on this measure of eye fatigue, she's found that the distribution follows a normal curve. Use that normal curve table to find out what percentage of students have z-scores below a z-score of 1.5. So the first thing we need to do in this problem is, if we're using the normal curve table, is find the z-score of 1.5. So I'm going to scroll all the way down, and here's a z-score of 1.5. And we have two numbers here. The percent mean to z says 43.32, and the percent in the tail says 6.68. So what did the question ask? The question is asking, again, so you have to use your head here. What percentage of students have scores below a z-score of 1.5? So we want to know, so in terms of drawing, a useful thing to do now is to draw out a normal curve. You don't have to be a perfect artist, just draw out a curve that looks something like this. And then the first thing to do is to kind of fill in, where is this question asking you to answer? So shade in the area under the curve. So shade in like an area of what is this question actually asking? And in this case, what it's asking is what percentage are below a z-score of 1.5, and it was a positive number. So imagine this number right here is a 1.5. This is the area percent mean to z. So it's asking what percentage are below that number. Well, you know that 50% over here is below the mean. So what it's really asking is, what is that 50% plus this portion that is the percent mean to z? And the percent mean to z is 43.32. So the way we would, if we were going to draw this, we would shade in all of this area plus this area from the mean score of 0 to the z-score of 0, the mean, to the z-score of 1.5. And we'd be able to add up 50 plus this number here, 43.32. If I add up those numbers, what I get is 93.32. So I take 50 plus 43.32, I get 93.32%. And so that's my answer. So for number 6, part A, so what percentage of students have z-scores below 1.5? The answer is 93.32%. So part B, it's kind of asking the inverse of that. It's asking what percentage of students have z-scores above that same point on our curve. So we already have a normal curve. Now if we know that 93.32, we're below that number, well, the rest out of 100% is going to be above that number. So let's go back down to our number. It'll just be in the table. So this is looking at the image here. It's asking what percentage are above this 1.5, and the percent in the tail is our answer. So it's going to be the 6.68. Another way to kind of think about that is, again, if we have 100% and we just found that 93.32 were below that z-score of 1.5, we could just take the full amount, the whole curve, minus the portion we already figured out, and the remaining bit is 6.68, and that's where, I guess, that number is kind of coming from. I hope that that is making sense. So if you pick, some z-score point in this table, and if 2 questions ask how many are above this number, and then the next question says how many are below that number, those 2 numbers better add up to 100%, basically. Now the next question, part C, is asking what percentage of students have z-scores below negative 1.5. And then the next one's going to say what percentage have a z-score above negative 1.5. So you'll notice in the table there are no negative z-scores. So what do? You don't have to look, you don't have to have the negative z-score in here. You're still going to be using the same number we actually just used because it's 1.5, and it works whether it's a positive number or negative number. You just have to kind of use your head. If we're going to use this table for the negative 1.5, we look at 1.5, and it's still the case that this 43.32 applies to the number between the mean and that z-score, but it is going to be reversed. So now that 43.32 is going to be an area right here between the mean and the negative z-score of negative 1.5. So if it's asking, let's remind myself, you have to keep going back and sometimes thinking about these questions. What percentage of students have z-scores below that negative 1.5? So again, draw it out. And if we're talking about what percentage are below that negative 1.5, if you draw it and then shade, what is the question actually asking about? You have to, here's a z-score of negative 1.5, let's say. It's asking just for this region right here. Well, what is that region right here? What's the inverse of that? So all it's really asking here is for this number, that 6.68 number. And if you look up the answer in the back of the book, number 6, part C, again, is the same answer as part B. It's 6.68%. And so we know the next question was asking what percentage are above that same point. And so that's going to be the same as our previous answer, that 93.32%. So just to keep going on with the trend here. So what I'm saying is part D asks what percentage of students have z-scores above the z-score of negative 1.5. So looking right here, again, you draw out the normal curve, figure out what the question is actually asking you to answer, and it's asking you what percentage are above the negative 1.5. So you'd again have a negative 1.5 z-score. Let's say it's around right here, and it's asking all of this area. Let's say from here, this would be shaded, this would be shaded, and this would be shaded. Now again, we know this is 50% above the mean, plus what? The portion from the mean to that z-score, which is 43.32. So we could again add up 50% plus 43.32%, and we again get that 93.32%. So then the next question asks about what percentage of students have z-scores above and then below a z-score of a positive 2.1. So finally, we'll use a different z-score number here. We'll find 2.1. So here's 2.1. And again, remind yourself, what is this saying? This is the percent mean to z. So if it's asking what percentage are above 2.1, you'd have to think about, well, here's the percent mean to z. It's asking about in the tail, the 1.79%. And if it's asking what percentage are below that, well, you could think of it as just 100% because the whole curve has to be 100 minus that 1.79, and you'd get 98.21%. Just to give you another way to think about that, it's 50% plus that 48.21. Because again, what it would be asking if you're talking about below this 2.1%, so let's say this is the z-score of 2.1. We know this is 50%. If it's asking what percentage of scores are below that point, it includes all of this area. So it includes the 50% that are below the mean, plus this portion that is between the mean and that 2.1, which is 48. So it's 50 plus the 48.21. So again, it is very helpful to draw it out and to shade in what exactly is the question asking. If you draw out the normal curve and shade in, what is this question even asking about? Once you shade it in, it should be easier to figure out how to use those percent numbers in the table to figure out the answer. So I think that's enough example for those sorts of problems in terms of finding the percentage. Now how about kind of the opposite, finding scores? Actually, let's take this one next. The next problem is dealing with the same problem, same conceptual idea, that is still in a measure of eye fatigue. This test of eye fatigue, now it's giving kind of specifics about that test. In terms of raw score, so far we haven't known what the raw score, the actual mean of this test was. We were only dealing with the standardized numbers, the standardized z-scores. The previous problem didn't say anything about what the mean was or the standard deviation. Now it's saying here the raw score mean and the standard deviation. So these are raw score numbers. So that's something you have to keep in mind with these problems is sometimes you're going to have to also convert from a raw score to a z-score or a z-score to a raw score in order to answer the question. So same sort of situation, but it says the test of eye fatigue has a raw score mean of 15 and a raw score standard deviation of 5. Now remember, in z-scores, a standard deviation of 5 is a the standard deviation, whatever it is a z-score of 1. One standard deviation above the mean is a z-score of 1.0. So it says, using the normal curve table, what percentage of students have scores, and in part A it says above 16. So we're still using that normal curve table, and this one actually feels trickier because we have to do some conversion with z-scores and raw scores. So what percentage of students have scores above a raw score of 16? Well, we know the mean is at 15, so the z-score of 0 is 15. So we know that the z-score it's asking about is going to be a positive number because it's one number above the mean. Now the standard deviation is 5, so it's not a full standard deviation. It's less than a z-score of 1. It's somewhere between 0 and 1 is what the z-score here would correspond to. So the first thing you kind of have to do is convert this score is asking about, this raw score, into a z-score, because until you do that, you're not going to be able to use that really it's a z-score table, that normal curve table we've been using. And you'd use the normal z-score equation to do that. And I can just do this in my head because I know that it's asking for how much of, so if a standard deviation is 5, it's asking how much of that, it's going from 15 to 16, you're only going to 1, so it's 1/5 of a standard deviation. So one way to kind of in my head quickly do it is 1 divided by 5 and we get 0.20. So it's 0.2 standard, a z-score of 0.2. It's 0.2 standard deviations. That's what the score of 16. If the mean is 15 and the standard deviation of 5, a score of 16 is 0.2 standard deviations above the mean. In other words, it's a z-score of 0.2. And I don't, if that's not totally clear to you, just use the z-score equation to figure out what do these numbers, what are they in terms of z-scores, and if you do the math, you'll get the 0.2. So again, the question's asking what percentage of students have scores above the 16. So really what's asking is what percentage of students have scores above a z-score of 0.2. So we go back to our normal curve table, and we find that 0.2 number, and it's right there. So it's asking again, what percentage have a score above the z-score of 0.2? And again, best thing to do is to draw it out. First, figure out what under this curve is the question asking about. So if it's asking right here, this is the percent mean to the z. How much is, we have shaded in, so to speak, between the mean and the z-score of 0.2, and it's just 7.93. But that's actually not what the question's asking about. If we shade it in the correct sort of way, it's asking what percent are above that point. So we would draw out a line to indicate our 0.2, and what it's asking is what percentage are above that. So really what's asking about is the percent that are in the tail from that point, which is 42.07. So I hope that makes sense in terms of how I figured that out. So the correct answer for A is 42.07. Next is asking what percentage of students have scores above a score of 17. Now, again, we have to figure out what the corresponding z-score is for a raw score of 17. So one way to do that, I can do it in my head. If we go from 15, that's 2 above 15. It's 2/5 of a standard deviation. So if I get 2 divided by 5, and we get a 0.4. So this was a 0.2, this is a 0.4, and I'll just tell you this is going to be a 0.6. If we had a score of 20, that would be one standard deviation above, so the z-score would be 1. But these are going up in 1/5 of a standard deviation increment, so it's like 0.2, 0.4, 0.6. So again, we've got, for the score of 17, we've got the z-score of 0.4. It's asking again, what percent of students have scores above that? So we go back, use our table again, we find the z-score now of 0.4, and we figure out what is the question asking. And again, it's the same as last time. It's asking really about the percent in the tail. So if you draw it out, and you draw a line where your 0.4, let's say this is a 0.4, even though it's not drawn well for that. Let's say this is the z-score of 0.4, and it's asking what percentage of students score above that. So you would shade in this area. That's just the percent in the tail. So we would just look here, and the answer is 34.46%. Score above a raw score of 17. So I hope this is making sense. So the trick here is you have to convert the raw score into the z-score so that you can look up what z-score is it asking about, and you have to figure out what under the curve is the question asking about. So the best way to do that is to first convert the score and then also draw out what is the question actually asking about, before you give your answer. And we can continue on. Part C is asking the same sort of thing. It's just asking about a 0.6. So think about where are we going to look? Z-score of 0.6. It's the exact same sort of situation. What percentage is above it? So if this is our z-score of 0.6, it's asking about the percent of the tail, 27.43%. And then below that same number, so this was above, so now it's just going to be the inverse of that. Let's see, so we're at 0.6. So it's going to be, so this is, it's actually a little trickier though, because it's just asking the whole percentage that is under the z-score of 0.6. So it's not just the 22.5, it's 50% plus 22.57%. So we're looking at 72.57%. So again, if you drew that out, just to kind of clarify, it's asking about, if you draw it out and write, okay, here's my 0.6, z-score, and we know that that's 22.57%. If we shade in, if you drew it out and shaded it in, what does the question actually ask about? It asks what percent is below that z-score of 0.6. So it's all of this area would be shaded and that area. So it's 50% plus the 22.57. That's where we're getting the 72.57%. And then the last one is asking about what percent are below a score of 14. Well, if you have drawn this out and you've been kind of, if you think carefully about this, we knew that for a raw score of 16, that was 1/5 of a standard deviation. It was just 1 out of 5, so to speak, of the 1/5 of the standard deviation above the mean. Well, this is going the opposite direction. It's going below the mean by 1/5 of a standard deviation. So this is kind of like the inverse, sort of of this question. So we have a z-score of negative 0.2 here. If you remember, this was a z-score of 0.2. Now it's asking what percentage have scores below a z-score of negative 0.2. So again, if we go back to our table, we find the z-score of 0.2. Again, always draw it out. And it's asking what percent is below a negative 0.2. And really what that, if you draw it out, the z-score is going to be below the mean. It's asking what percentage are below that. So really what it's asking is what percent are in the tail from the z-score to the tail. So really we're going to be looking in the percent in tail column, and it's going to be the 42.07% is the correct answer. All right, so that's it for question 7. And then question 8. Again, following along with the same sort of example, it's saying in the eye fatigue example, and by the way, the eye fatigue, the details about what the example is are kind of irrelevant here. We're dealing with just a normal curve distribution. So the numbers are really what's relevant. Question 8, in the eye fatigue example from number 6 and 7 that we just did, again, use the normal curve table. What is the lowest score on the eye fatigue measure a person has to have to be in the top 40%, top 30%, and then top 20%. So this is very different. In problem 6 and 7, we were answering with a percentage. It was asking us what percentage of students fall under this area of the curve. In this one, it's giving you a percentage, like a point on the curve, what percentage are above this point, and you have to figure out, in this case, it's asking about what's the lowest score. So if it says score and not z-score, then it's talking about the raw score. So again, this is going to be tricky because you're going to be looking at the table. First, you got to find out where the question is talking about in the table in terms of z-scores, and that's not going to be the full answer because after you know the right z-score, then you have to convert that z-score into a raw score using the equation that we've seen earlier. So let's go through this. The question is, what's the lowest score that a person has to be in the top 40%? So how are we going to figure this out? Now we're going to use the mean and standard deviation that it gave us in problem 7 to answer this. We're going to go up to where it's asking about what's the lowest score you to be in the top 40%. Well, what we really want to know here is what's the cutoff to have to be where there's 40% in the tail. So as I scroll down in this, it wants to know the minimum kind of cutoff right here, where there's basically 40% above that point. So if I go down here, I want to look what's closest to 40%. And this can get tricky in particular because the percentages that you get are basically never exactly the number that you're looking for. So in this case, we're looking for what's the minimum score you need to get to be in the top 40%. And in short, you're looking for the closest answer. And I promise that on an actual test, I'm not going to be very nitpicky on a particular answer right here, or it's multiple choice. So it looks like it could be 0.25 or 0.26 because that's where 40% would lie, somewhere between them. In this case, the answer is the 0.25 z-score. So we're looking right here. Here's the z-score column. Now that's not the full answer because again, the question's not asking for the z-score. The question's asking for what's the minimum score in terms of a raw score. So we know the z-score is 0.25, but the question is asking what's the lowest score on the measure that the person has to be in the top 40%. So we want to know, we're going to use the z-score equation to convert that 0.25 z-score into a raw score. So the way that we do that is we, again, use the z-score equation. And again, what that looks like is z x minus mean divided by the standard deviation. So we know, and we have to rearrange that. The z-score was 0.25. Let's see. Okay, and we're solving for x here. Minus, and again, the mean comes from this previous problem. We have a mean of 15 and a standard deviation of 5. So when we rearrange that to solve for x, it's going to be 0.25 times 5. Do that first. And then plus the mean. And that's going to equal what we're looking for, which is the x, which is the raw score. So you just solve it like this. If I take 0.25 times 5, I get 1.25. And the mean was 15. So again, also think about, does this make sense for the question? The question was asking, what's the lowest score a person has to have to be in the top 40%. So if they're in the top 40%, you know that's above the mean. So the score you get should be above the mean. And ours will be, because if we take that 1.25 and add the mean to it, 15, which comes from right here, we get 16.25, and that's our answer. So for part A, the lowest score a person has to be in the top 40%, the answer is 16.25. And that makes sense because that number is above the mean. So part B is asking about what's the lowest score the person has to be in the top 30%. Well, same sort of thing. We go into the normal curve table, and we have to find a number that closely corresponds in the percent in the tail to 30% instead of 40 this time. And so when we look it up right here, we see that 30 is between right here. So we take the z-score of 0.52, and we would do the exact same thing. So again, just to reiterate where we got that, this is the percent in the tail, and the question is asking, again, it's always useful to draw it out. The question is asking, what's the minimum score to be in the top 30%? So you want to know the top 30% is always going to be the percent in the tail, so you want to know the cutoff to be in this top 30%. So that's why we were looking for the 30% number and the percent in tail. And that's where we got the 0.52. So if we go back down and do the same sort of thing, using that same, instead of 0.25, we have 0.52, and we have the same standard deviation, the same mean as we were using before. So it's going to be set up the same sort of way. We're solving for x because we want to know about the raw score, not the z-score. So if I take 0.52 times 5, I get 2.6 plus 15, and I get 17.6, and that's the answer I'm looking for. So to be in the top 30%, you have to score a 17.6. And again, that makes sense because obviously it's above the mean. 17.6 is above 15. Okay, so that's how you solve these problems using the normal curve table. I hope this was helpful. I know these problems can be tricky, and I wanted to give you a visual for understanding it.